Good evening. In this video, we are going to work out one of the more concept question extracted from 2013 science paper 3. This is the question that we are going to work out together. You can read through. A. Question A reads, define reactive molecular mass. So reactive molecular mass, this is just the average mass of one molecule of a substance compared with 12 gram, the mass of one atom of carbon 12. So in short here, reactive molecular mass, this is the total mass. This is the total masses of each atom in that particular compound. So for example, if you've got, let's say, sodium chloride, the total mass of sodium chloride is what we are calling as the reactive molecular mass, meaning we are going to sum together the total masses of that particular compound. So it is just simply the sum of reactive atomic masses. That is what reactive molecular mass is. Coming to B, potassium carbonate reacts with dilute sulfuric acid to form potassium sulfate, carbon dioxide gas, and water. Construct a balanced chemical equation including state symbols for the reaction above. So here we are asked to construct a balanced chemical equation, and we should also include state symbols. So here we are told what the reactants are and what was produced. So the reactant were potassium carbonate reacting with dilute sulfuric acid. So you are going to write these equations using chemical formulas. So now you are going to write the formula of potassium carbonate reacting with sulfuric acid. So now in case maybe you don't know what potassium carbonate, the formula of potassium carbonate, what you are going to do is there are two entities there. We have potassium, which is an element. You also have carbonate, which is a radical. So now you are going to formulate a formula of potassium and the carbonate. So you write first the symbol of potassium like that. If you don't know, you write it somewhere separate. And then we have carbonate. Carbonate is a radical. So you are going to write a symbol of carbonate, which is CO3, like that. After doing that, you are going to indicate their valence numbers. So potassium, it is coming from group 1, therefore it has got a valence of 1. You write it on top like that. Then you come to carbonate. Carbonate is a radical and it has got a valence of 2. You also write it on top. From there, you are going to interchange their valence numbers. So you are going to interchange, the 2 will come to potassium and the 1 will go to carbonate, like that. Therefore, when you interchange, it is going to look like that. So to carbonate, I've introduced the open and close parentheses because carbonate is made up of 2 different atoms, carbon and also oxygen. And that one, when it go the other side, it is going to carbonate, not just oxygen. Therefore, I have enclosed them in the open and close what? Parentheses. Now that the one we don't show it, so we are going to leave our formula like that. So we are going to have potassium 2 and then carbonate. So that is the formula of potassium carbonate. Now here we also have another compound that you need to figure out if you don't know how to write it. Potassium sulfate. So here it's just the same thing. You write the symbol of potassium like that. From there you write the symbol of sulfate. Sulfate, it is SO4, that is sulfate. And then you write their valence numbers on top like that. And then you interchange like that as usual. From there the formula will look like that. And officially now, after removing the one there, that is our potassium sulfate. That is how it is going to look like. From there now, you substitute, you formulate now the equation. So you're going to say potassium carbonate plus dilute sulfuric acid. So the formula of sulfuric acid, it is just H2 and then SO4. So this is how it is going to look like. Before that, they say when you add acid, when acids react with metal carbonates, they produce salty carbon dioxide and water, which we are given here. So as long as there's acid reacting with any metal carbonate, they form three things: the salt, the carbon dioxide, and also the water, which we are given here. So in this case, our equation is going to look like that: the potassium carbonate plus sulfuric acid, giving us potassium sulfate plus carbon dioxide plus water. So that is our equation there. So we have to make sure that this very equation, it is balanced, and we should also include the state symbols. So when you check, I can give you some time to check, to go through it. You may find that with this side we have 2 potassium atoms. The other side also we have 2 potassium atoms. When you come to carbon, we have 1 carbon this side. The other side also we have 1 carbon. When you come to oxygen, in the first compound there we have 3. Then in the second one there we have 4. So this side we have total 7. Coming to the other side, to the right side, we have 4 oxygen atoms in the first compound. Then the second compound we have 2, making 6. Then the last one we have 1, making 7, meaning 7. So oxygen atoms are balanced. So we are lucky, ladies and gentlemen. This very equation that we have here, it's already balanced. Therefore, what is required of us is just to write the state symbols. So when you write your state symbols, this is how the equation it is going to look like. So the first one there, it will be solid, and the second one there, the acid will be aqueous. Remember, it is dilute, meaning some amount of water was added there. No wonder it is aqueous. And then coming to potassium sulfate, also there it is aqueous. Then carbon dioxide, it is a gas. Carbon dioxide, it is the air that we breathe out, so it is gas. And then water, usually it is liquid. So we write air there as a state symbol. So that is our well-balanced chemical equation. Coming to B2, calculate the mass of potassium sulfate produced when 2 grams of potassium carbonate reacts with an excess of dilute sulfuric acid. So here what they want us to do is to calculate now the mass of potassium sulfate. Potassium sulfate, it is the product that was produced when we reacted potassium carbonate plus the sulfuric acid. So we are told that the sulfuric acid, it was in excess, meaning it was more compared to potassium carbonate. Potassium carbonate, we only had 2 grams of it. Therefore, potassium carbonate, it is a limiting reagent, and it is always the limiting reagent that determines the amount to be produced. So in this case, what we are going to do is we are going to convert this gram. As usual, from my first video under more concept, we said that whatever we are given, as long as it is not in moles, we have to make sure that we convert that to moles first. That is the thing, because moles are usually general. They help us to find any different amount that we want to find. Any different quantities that we want to find. So we are going to to convert this gram to moles. So quickly, you should identify the right formula that you can use in order to convert this mass to moles. So they are quite different number of formulas that we use to find the number of moles. So you look at what we have. So in this case, we have the grams and also the chemical compound, the chemical name of a compound. So in this case, this is the formula that we are going to use. Number of moles is equal to mass over the molar mass. So the mass we have, which is 2 grams, and the molar mass, that is the relative molecular mass of potassium carbonate, because this 2 gram, it is for potassium carbonate. So you're going to find the formula, the relative molecular mass of potassium carbonate, and then you substitute. So when we substitute the relative molecular mass, it is 138. You can try it on a piece of paper and then see how you see what you can get. So our mass there, it is 2. Then the molar mass of potassium carbonate. Potassium, there are 2 carbon atoms. There are 2 atoms of potassium, and potassium has a mass number of 39. So we are going to say 2 times 39. It will give us something. Then we have 1 carbon, meaning times the mass number of carbon, which is 12, giving us 12. Then we have oxygen, 3 atoms times its mass number, which is 16. It will give us 48. When you add it together, you will get 138. So when you divide that now, this is what we are going to find. So number of moles of potassium carbonate is equal to 0.0145 mole. Then after doing that, what we've done, we've just converted the 2 gram of potassium carbonate to moles. So these moles are for potassium carbonate. We've not touched the mass of potassium sulfate. So now, after finding this number of moles, here is what we are going to do. You are going to bring out that balanced equation. You don't have to leave it out like that. Then, what you are going to do is you are going to compare the mole ratio. The mole ratio of what we want to find and also what we've been given. In short, the one which is limiting the reactant. So we are given the one which is limiting the reaction. So we have potassium carbonate here. So the potassium carbonate will be compared to potassium sulfate. We are using potassium carbonate because it is the one which is determining the amount of products that are going to be produced. Or it is the one which is given, in short. We are using also potassium sulfate because it is the one that we are trying to find. So there's no way we can go to carbon dioxide when you are asked something else. So meaning we are going to compare these two. Potassium carbonate, this one we are given, and it is the one determining the amount of products to be produced. And then the potassium sulfate there, it is the one that we are working for here. Then we are going to compare their mole ratios. What we mean by mole ratios is the coefficients. They are numbers in front of a balanced chemical equation. So for potassium carbonate, the number in front there, it is simply 1. The other one also, there is no number that we are seeing there, so it is simply 1. So meaning the mole ratio, it is 1 to 1. From there, we are going to write the number of moles of potassium carbonate. We are given. So it is 0, we've already found. So it is 0.0145 moles. And then for potassium sulfate, that one we don't know. It is the one that we are trying to work out. So meaning you compare like that. Meaning here we have this number of moles, then the other side, we don't know the number of moles. So you say X. Then from there now you cross multiply like that. So when you perform some calculations, this is what you are going to get. Number of moles is equal to 0.0145 mole of potassium sulfate. So these moles now are for potassium sulfate. At least we have something about potassium sulfate. We had nothing. So now, how do we find the mass now? So we are going to use that same formula that we started with there, where we say number of moles is equal to mass over molar mass. So the moles we have, the molar mass we can find. Here now the molar mass has to be for potassium sulfate, not the one that we used there for potassium carbonate. So here now, these moles now that we found, the second moles, these are for potassium sulfate. So we are going to convert these moles back to mass. Remember, for potassium sulfate. So you substitute your equation like that. Number of moles there is equal to mass over the molar mass of potassium sulfate. So potassium, there are two atoms of potassium there, as you can see from there. And then we have sulfur, one atom. So 1 time is 32, its mass number. You give us 32. Then we have 4 oxygen atoms times 16, which is 64. When you add together, you're going to get 174. Then you cross multiply like that. So M times 1, you get M, and then 0.0145 times 174. When you multiply this, you are going to get 2.52 grams. That is the answer that is the mass of potassium sulfate. So that is how you should work it out. Coming to C, what is the identity test of the gas produced in the reaction above? So when you check the reaction there, which gas is there? There's only carbon dioxide. So what is the identity test of carbon dioxide? So this carbon dioxide you are seeing, its identity test is it turns lime water milky. That is the identity test for carbon dioxide. It turns lime water milky. Thank you so much for watching.